5G Clarity is a 5G PPP project phase 3, H2020 ICT 10, and beyond 5G multi-tenant private networks integrating cellular, Wi-Fi, Li-Fi, powered by artificial intelligence and intent-based policy. You can find more information on our on the project website, 5gclarity.com. And also, we will have a couple of presentations on the innovations by the 5G Clarity and the structure of the project. My name is Mir Goreshi. I'm from GigaSys Solutions, and I'm project manager at 5G Clarity, and I'm honored to moderate this experts panel. Today's program includes four presentations by our distinguished experts on the topics that you can see on the screen. First, we will have a presentation by Jose Lucena on MNOs and private 5G networks, a perfect catalyst for industry digitization. Jose is from Telefónica Spain. Then Alain Morad from Interdigital UK will provide his insights on technology trends towards 6G. And Daniel Camps-Moore, the 5G Clarity Technical Coordinator, will present 5G Clarity innovations beyond 3GPP Release 16. And finally, Jesus Gutierrez, who is also 5G Clarity Coordinator and Project Manager at IHP Electronics, will provide a presentation on localization in 5G networks using RAT-independent technology. Non-public networks have attracted a lot of attentions in the recent months and days. And that's because of its specific and unique opportunities which can provide for the verticals and for the users and customers. These will be discussed in more details specifically in the presentation by Jose, where he will provide also insight into deployment scenarios and also the role of MNOs in this area and how MNOs will look at this technology trend. Then Alain will provide us with updated insights and details on the technology trends beyond 5G and towards 6G in a well categorized fashion. He will explain the technology trends and services and also target capabilities where those technologies trends are aiming at, and also key forums and features in this road. Daniel then will give us in-depth insight into the 5G Clarity project, motivations, objectives, the architecture, the innovations which has been worked out and targeted, and also use cases which are targets of the project. And finally, Jesus will give us a further detail on one of the enablers for this project, which is on positioning and localization, the individual technologies and the hybrid approach to use those individual technologies and merge them, the merging approach, and then innovations used in these hybrid approach as well as individual approaches, and also a specific use case for this. And by this introduction, I don't take any more time of our experts, and I will pass the token to Jose to provide his excellent presentation on MNOs and private 5G networks. Thank you.
Thank you, Mir.
I need to stop sharing. Yes, please, you can go ahead.
Okay. Let me try to share my screen. Let me see. Okay, let me know if you can see the full screen mode here.
Not yet, Jose.
Yes, we
now
can
yes.
see now, yes.
Okay, perfect. So thanks for the introduction. Hi everyone, my name is Jose. I'm a core and platforms technology analyst working in the technology innovation and standardization activities within Telefonica Group. And in this session, I'm going to provide the operator's perspective on the adoption of private 5G networks. First, we will see the rational drivers of these networks, clarifying how they may unleash an age of pervasive connectivity and awareness that will foster entirely new modes of customer interaction and service delivery. Then we will focus on the realization of these private 5G networks, seeing the role that the MNO plays in the provisioning and operation. And finally, we will see 2 success stories where Telefonica has participated in related to 5G private networks. So without further ado, let's get started. So this first slide captures the key aspects and driving factors for private networks and the use of 5G on them. You may know that today we have Wi-Fi or private LTE networks, which have existed for years as an add-on capability to public cellular 4G systems. And these solutions have been traditional, sufficient to enterprise customers willing to have an on-premise network solution. So one could ask himself is, why 5G is needed now? Well, with the ongoing digital transformation, enterprise and industrial customers are starting to move business to the cloud-native management, including critical applications, which heighten the demands for increased mobility and throughput. And in addition, the recent innovation technology in automation and IoT applications in a variety of vertical industry sectors required added security protection and enhanced data privacy. So satisfying these requirements are either impractical or not possible within the limitations of Wi-Fi networks or private LTE networks. And in this regard is why 5G technology is definitely needed now. And 5G private networks are becoming both more tangible and inevitable for enterprise customers to remain competitive. 5G not only delivers superior coverage and mobility compared to existing radio and wireless technology, but also innovative system-level capabilities such as network slicing, edge computing, or service-based architectures. And this will ensure the technology meets the needs of upcoming verticals, will increase their confidence in their roadmap, and will serve to accelerate service innovation through new use cases. Private 5G networks have become one of the telecom industry most promising growth sectors, with analysts estimating it to become a $60 billion industry in the next 5 years, as shown here. By focusing on specific IoT applications and services, private 5G networks are the ultimate solutions for companies who need an independent, enterprise-grade wireless network with all the benefits that 5G technology can offer, such as data privacy, enhanced security, flexibility, low latency, enhance performance, network reliability, and so on. And the new area of private 5G can open multiple opportunities for multiple applications with different requirements. Here in this figure, we can see the use cases from the top ranked vertical industry that will benefit most from the use of private 5G networks. These are the utilities, oil, gas, mining, manufacturing, transportation, and public and enterprise venues. And all this context is framed in a competitive landscape with a shaping role model that involves new provider-customer relationships. In fact, 5G private networks ecosystem represent a significantly leap forward with respect to purely based public network scenarios, considering now that we have the involvement from resources from multiple access technologies, as well as the interoperation of public and private infrastructures for the provisioning of these non-public services. And to capture all these novelties, the original 3GPP rodel model we have seen for some time needs to be extended, resulting in this diagram. So on the one hand, we see that the private and public roles are decoupled to keep in-house management and orchestration separated from the provisioning activities executed on the PLMN. This decoupling ensures the private network can be operated independently of the PLMN, facilitating the realization of standalone scenarios. And for public network integrated NPM, we have the network service aggregator, which provide the necessary means for this integration between the PLMN and the private infrastructure. On the other hand, additional roles are defined. We have the wireless access technology service provider, the wireless access technology aggregator, and the on-premise cloud service provider. And these new roles allow for dealing with the on-premise operational aspects. The WAT service provider allows for indoor coverage using one or more wireless access technology, including new radio, Wi-Fi, and Li-Fi. The WAT aggregator, what allows is federating different access technology together for a unified and consistent management of wireless resources when used in conjunction. And finally, we have the on-premise cloud service provider, which provides infrastructural services leveraging the use of edge clusters. And these clusters are built out of small-sized servers, optimized for the use of local data networks and typically provisioned with hardware acceleration solutions. In the next two slides, I will try to capture the archetypal deployment scenarios of 5G private networks in the two categories that 3GPP has defined thus far. We have the standalone NPMs and the public network integrated NPMs. This first slide captures the standalone NPM category. A standalone NPM represents a private 5G network that does not rely on functions provided by a PLMN. And here we can see four representative scenarios. The first scenario represents a deployment model where all the private network components are deployed on premises. This usually is due to security reasons, high availability reasons, or to avoid control and data traffic thrombosing via the public 5G core. And the complete separation of NPM from PLMN is manifested in three main perspectives or aspects. First one is the assignment of dedicating spectrum, either obtained from the local regulator or leased from the MNO. Secondly, the presence of private RAM, consisting of small sets for exclusive use of enterprise users. And third is the lack of presence of PLMN functions along the entire data path from the access to the local data network. Indeed, we see all the components are owned by the enterprise or industry customer. The second scenario is similar to the previous one, with the difference that all the works that could be virtualized are moved to the public cloud. And by doing that, the customer transfers all the integration efforts and capacity management activities to the corresponding public cloud provider, which is typically an hyperscaler, at the cost of allowing traffic to leave the customer side. The third scenario is the natural evolution of the second one, applying the same architectural blueprint to customers that have two or more managed sites, for example, bank offices, enterprise branches, and so on. And finally, the fourth scenario represents a model quite different from the three previous ones. Here, the small cells are made available for RAN sharing, with the enterprise customer playing the role of neutral host. As you may know, the neutral host represents, let's say, a role whereby the enterprise invests in on-premises network infrastructure and monetize this infrastructure by selling coverage solutions to different MNOs. And the benefit for hosted MNOs is that they can increase their coverage area without the need to invest themselves in the on-premise equipment, thus expanding their service footprint at a much reduced costs. And candidate infrastructure where neutral hosting model makes sense include Stadia, include smart city facilities, include transportation hubs, and so on. And this second line, we have the second category, which is the public network integrated NPN, where the private 5G network is now deployed with the support of one or more PLMN IDs, and therefore with the support of MNOs. And here as well, we have 4 scenarios. The first one represents a model whereby the NPN is fully integrated with the MNO commercial network, with the exception of the radio access, which is located on customer premises and based typically on public spectrum. Indeed, we see that the UPF, the control plane, and the UDM are provided by the MNO. And to keep segregation between the traffic from MNO users and the traffic from customer users, typically data network name-based solution as defined from 3GPP are to be applied. The second scenario represents a paradigm shift compared to the first one by replacing DNN-based solutions with the use of network slicing technology. In this deployment model, the MNO provisions dedicated UPF, control plane, and UDM for the NPN in the form of a network slice, which is entirely hosted by the MNO's infrastructure. This means that user traffic, signaling traffic, and subscription data are transferred out of the customer premises. And it is the MNO who applies the necessary policies to ensure this slice is only accessible by non-public subscriber. For example, by linking the single NSSI with the close access group identifiers, that are the 3GPP mechanisms that are defined to that end. The scenario number 3 is similar to the second scenario, with the exception that user traffic is kept on premise. Okay, the decision for a customer to go for this is typically because latency constraints between devices in the same location, or to reduce thrombosing of data into the MNO and then back out again into the applications. And finally, we have the fourth scenario, that is the extension of the third one, but apply also to customers who have multiple managed sites, to different branch offices and so on. As we can see here, we have some service applications that are kept locally, for example, those applications for ultra low latency services, while we have some applications that could be hosted at MNOs, for example, those that are used for massive IoT. So we can split the service applications across the 2 administrative domain, depending on the service requirements of the use case they serve. And in all the scenarios seen so far, you may have noticed the presence of public macro RAN. But the question here is why the public RAN is relevant for private 5G networks if we have said that there exists internal coverage with private RAN. Well, there are scenarios where devices go out of private RAN coverage, either because of an emergency situation, for example, in the case of a completely breakdown of the on-premise infrastructure, or because of mobility scenario, for example, when the customers may move out of their premises. So to cover these scenarios, the public RAN is used as an alternative. And to make it happen, the device subscription profile, which is stored in the private network UDM, shall be reachable by the public MNO core. And this interaction assumes the 2 requisites and requirements stated here. First, the use of public insync range for the private 5G network, and second, the use of a specific PLMN ID for the private network and configuring the device as preferred ID. So with this setup, when a device goes out from private radio coverage, it will try to connect to the public mass market radio. And during that connection, the MNO public core will treat this device as a roaming user, and it will contact the UDM home network for device authentication and access parameter. And this basically allows for these use cases to have the service continuity they need and to avoid any sort of service disruption, thanks to to this configuration. Now that we have all the context, it is time to focus on the MNO view of private 5G networks. The rollout strategy is a recurrent topic that acclaimed technology analysts have surveyed in the last months. One of the most recent surveys is this one from Heavy Rating, where the operators are asked to specify by when they expect the private 5G market to take off. Some insights from this survey show that small-scale 5G networks are expected no later than 2022. However, respondents are realistic that 5G is a medium-term opportunity for the operator mainstream enterprise market, and over half expect 5G to be mainstream from 2023 on later. So according to this result, it is clear that standalone NPNs will be the first one to be commercialized. 5G innovation here is relatively easy since there is almost no legacy. However, having greenfield environment does not mean low cost for sure, but just the opposite. I mean, the fact that customized 5G networks need to be set up for a very specific customer makes CapEx and OpEx quite high, making this option only affordable by large size companies. However, we expect that as the technology of 5G matures, the transition from totally and entirely isolated private networks to public integrated MPNs, like hybrid private networks, will be reality. And this will allow deploying private 5G networks at large scale, dramatically reducing costs and making them affordable for most of enterprise and industry customers. And in the next slide, what I try to explain is why the MNOs are necessary for private 5G networks, why the position of MNOs is relevant in the private 5G networks, and clarifying basically the private role from different aspects. So the first reason we see is that the use of network slicing technology for the realization of public network integrated MPN to the customer. Thanks to network slicing, we can bring agility in their provisioning together with tailored service-specific programmable capabilities at top. And to that end, the operator may leverage a network slice as a service model, as captured in this figure. And the applicability of this service delivery model for the provisioning of NPNs is rather simple. So on the one hand, the network operator takes the slice provider role, offering to the vertical the required network resources, function, and services from the public network in the form of a slice instance. And secondly, the vertical takes the slice customer role and consumes the slice instance received from the operator and extended it with his own network functions. And with this approach, what the vertical sees now is an end-to-end network composed of two differentiated segments. One public, provided by the network operator as a network slice instance, and another private, consisting of those network functions deployed on premises. And this service delivery model and their use for the NPN is something that in Telefónica we are exploring and assessing in ongoing 5G PPP projects, with ICT 17 behaving as the MNOs, let's say, and the ICT 19 behaving as the verticals. And as seen in this figure, we use network slice service model for the provisioning of public network integrated MPNs, with the ICT 19 facilities delivering a slice to the ICT 19 and the ICT 19 extending the slice with its own network functions and thereby allowing the realization of the entire public network integrated NPN. That was the first reason. The second reason is the use of one connectivity services to facilitate the multi-site integration. So there exist scenarios where the NPN assets are entirely deployed locally. The truth is that there are some scenarios where some of the workloads need to be deployed out of the customer premises, basically for cost reason. For example, one of these out-of-premise node could be the telco edge cloud. So to allow the traffic, the data control and management traffic to go between the premises, the private premises, and these hosting telco nodes, the telco edge cloud, the operator needs to provision data networking services based on WAC technologies. And this table captures examples of these one connectivity services, providing a comparative analysis among them in terms of topology, isolation, quality of service, and cost. We can see, in fact, a wide range of options from completely dedicated connectivity pipe based on the use of wavelength to purely overlay solutions, for example, SD-WAN. And the selection of one or another solution is basically up to each customer, depending on how much money they are willing to pay and the service requirements from the use cases and applications. And the third and the last reason why we believe that the MNO is essential for the private 5G networks landscape is that the MNO has the real know-how on getting networks up and running. So the proving experience of MNOs of managing a wide variety of networks, from transnational mobile and fixed networks to local enterprise networks, makes the MNOs a perfect ally for verticals, particularly bearing in mind that most of these verticals are new to the telco and networking world. While for a vertical, a private 5G network is a complex fabric of resources, functions, and services with behavior that needs to be monitored 24/7, for a telco operator is another island among the many others it operates and maintains every day. So based on this rationale, it is clear that offloading complex operational issues of the private network to the MNO not only leads to OpEx reduction for the vertical, but also allows the vertical to put all the efforts on their businesses, on their services, focusing on service innovation and process optimization, and leave all the network-related complexity to the MNO. And that's why operator here, based on the proven experience, is a perfect ally for the verticals, helping them with the design, installation, setup, and operation of the NPN throughout the entire life cycle. And this plot captures precisely the benefits of this approach, showing how it can be a catalyst for shorter time to market and reduce costs. For sure, there are situations where the customer wants to retain control and management of some specific parts of the network. And in such a case, hybrid solutions can be defined, with operator taking the lead on the control and management activities, while exposing needed capabilities to the verticals through well-defined APIs. And this figure shows what this capability exposure is about. As seen, the operator has a functional framework that allows consuming internal network-centric APIs and transforming them into user-friendly APIs, for example, the Inform Open APIs, that are to be securely exposed through an API gateway to the vertical, thereby allowing the vertical to consume the network and management capabilities they need according to the use cases. And note that also that this capability exposure needs to be accompanied with non-reputation mechanisms that allow keeping track of all the request response messages exchanged between the operator and the vertical. For sure, here auditability and all the traceability of all the requests is essential in this new openness ecosystem that 5G networks and private 5G networks will allow. And I don't want to finalize this presentation without talking about two success stories on private 5G networks where Telefónica has participated. On the left side, we can see an automotive use case with Daimler. Daimler is putting in place the world's first 5G mobile network for automobile production in its factory 56 in Germany. And this private 5G network has been installed by Telefónica Deutschland in collaboration with Ericsson. And the use of 5G network technology here allows Mercedes-Benz cars, among other things, to optimize existing production processes, such as data leaking or product tracking on the assembly line. And on the other side, and another use case is this one, is a retail use case, where Telefónica has implemented a private 5G network in the Madrid logistics center of Spanish retail giant El Corte Inglés. The aim here is to apply the Industry 4.0 concept to the worlds of logistics by optimizing the retail chains, processing of parcels, and classification. And a number of use cases are to be trialed here. Here you have, below you have the sources of these success stories in case you have to get some more detail of these use cases. And that's what I want to share with you in today's session. Thank you all.
Thank you very much, Jose, for your very useful information in clarifying the stance of operators on the topic. I just emphasize that if audience have any questions, please post it into the chat box. We can go through one question after each presentation if there is time, and then we leave the rest for the end to be discussed all together. I have a short question here, which Jose may answer now, and then we take the longer one for the QA and discussion time after all presentations. The question says, how do you see potential problems with qualified staff that will run, manage, and maintenance or maintain private networks?
Well, so as I said before, the MNOs have experience with operating a wide variety of variants of networks, from large-scale network, transnational, mobile and fixed network to the local enterprise network. So maybe the challenge here is how to integrate all the complex technology we foresee for private 5G networks, not only 5G core with the 5G RAN itself, but also to allow the integration of Wi-Fi with another technologies, industrial technologies, as for example, TSN, and also to link this with the legacy. Maybe some parts of the network need to be kept with a fixed access. So how to operate and orchestrate all this wide variety of technologies all of the same time, maybe it will be the challenge for us. And I mean, this is at least as I said, but I mean, keeping in general the orchestration of multiple networks should not be a problem, because we have the proven experience on that. And maybe for the very specific integration issues, maybe we need help for system integrators to help us and prepare everything and just make them work for us to operate the entire network itself.
Thank you very much. I think clear enough. Thank you very much, Jose, for your excellent presentation and discussions. We can go now to our second talk by Alan Murad from Interdigital on technology trends toward 6G. Alan, you can share your screen now.
Yeah. Can you see the screen now?
Not yet. Yes, now we can see, but it's not full screen.
Okay, and I think I need to swap to the, yeah. All right. So you can see it in full, right?
Yes, now we can see it.
Excellent. Good. So thank you, Mir. Good morning, everybody. My name is Alan Murad. I'm with Interdigital in London, in the UK. And my talk is on the technology trends towards 6G. So it's not exclusively private networks, but obviously private networks is a component of these technology trends to 6G. So I will start first with some mega trends actually that are underpinning the path to 6G. 2 market trends and 3 technology trends. So the first market trend is quite obvious, with the ongoing race for 6G research leadership across multiple regions. The second market trend is this momentum that's gathering for the support of more and more verticals. On the technology side, 3 mega trends. The first being on the rise of data-driven networks with artificial intelligence and machine learning. The second mega tech trend is on the widespread virtualization and disaggregation. And the third is on the drive for new spectrum and new regulation. So the first market mega trend on the stakeholder race for 6G research leadership So we clearly seen a number of programs already launched or launching in various regions, like in Europe, in the States, in China, in Japan, and Korea. And these are like multi-year, multi-billion kind of programs aiming at achieving some form of research leadership position in 6G before it hits the standards. So all these programs are creating actually the need for the R&D community to come together and start some form of harmonization effort. And such harmonization effort on the system vision, technology trends, and requirements has already actually started recently. For example, in the ITUR, with that vision on the IMT 2030 that I will touch upon later on in my presentation. So the second mega trend on this momentum that's gathering for the support of more verticals. So clearly, verticals have been a main differentiator actually in 5G as compared, for example, to 4G. And the story for vertical support in 5G has only started actually. So this is just the beginning. So we are already actually seeing on the evolution of 5G and standard bodies like the 3GPP, some further evolution of the use cases driven by fora like 5G Asia in Europe and its equivalent 5G DNA in China, trying to push actually use cases that cannot be met today with the release 16 of 3GPP for 5G. So clearly, the verticals have a rich roadmap of use cases that will challenge, increasingly challenge the performance KPIs of current 5G and will drive actually further enhancements and advancements of 5G all along up to 6G. Moving to the second, the first mega trend on the technical side. So this is the rise of AI/ML and data-driven networks. So yes, AI/ML is a big buzzword now. Wherever you go, there's AI/ML. But also, let's face the reality, actually, AI/ML is already deployed and deeply penetrated in market solutions, be it for the web technologies or network technologies, but also chip technologies. Okay? And it's this trend of including or leveraging AI/ML tools in various sectors of the network will only continue as these tools mature and more data become available. So what's the impact of AI/ML on the wireless network design towards 6G? So AI/ML, indeed, they have the potential to disrupt completely the design of the future wireless networks and devices. And that's in the core, in the access, in the edge, but also on the device itself. Moving next to the mega trend on the virtualization and disaggregation. Well, if we say 5G, it's intertwined with virtualization somehow. So virtualization is already a reality in the core, but also on the edge. And we are clearly seeing a momentum gathering for supporting virtualization into the radio access network as well, with initiatives like ORAN, SDRAN, OpenRAN, ONF, TIP, and the likes. So this trend, which already started, is disruptive, not only from the technology point of view, but also from the business point of view as well, and regulatory point of view. And it is indeed envisioned that this virtualization of the RAN and disaggregation of the RAN is a trend that will only, that will take us actually until 6G to realize the full breadth and depth of the possibilities there. So the third mega trend here is on the drive for new spectrum and new regulation. So I think if we start from 5G with key differentiator to 4G, so certainly there has been a move to millimeter wave frequencies, so move for higher frequencies. But also importantly, and that's quite relevant to the private network discussion, the first time actually private licenses have been allocated in Europe for non-telcos. So this trend on the further dedication of licenses for the private networks is going to continue in the evolution of 5G. But also, we will see further drive to support frequencies above the 100 gigahertz gap today in 5G. So the impact on exploring frequencies as high as 100 gig and above is pretty much a complete redesign that this requires on the radio interface, right? With multiple elements that need to be re-engineered, including aspects like waveforms, codecs, MIMOs, and medium access protocols. So this is like an overview of these mega trends, 2 on the market side and 3 on the technology side. Now I will deep dive on the target capabilities and technology trends on the wireless side, on the wireless interface side, but also on the network side as well. Starting first with just a landscape in terms of key fora that are stakeholders into the development of the evolution of 5G all the way up to 6G. So obviously here we have research fora like the European Union Framework Program, Horizon Europe. We have other fora like the ITUT with its focus groups exploring machine learning for 5G and beyond, and Network 2030 kind of visions, and additional emerging technology kind of focus groups on AI, distributed ledgers, quantum communication, and the like. And quite importantly, for this presentation today is this ITUR, which we'll focus a little bit more on next, which is the body that is in charge of the IMT system recommendations, with recommendations already for the IMT 2020 released earlier this year. And then the work for the IMT 2030 already started. Next, as we move further down, actually from the research to the standards, we see the standard bodies like ETSI, both with its pre-standard working groups and standard working groups, covering a large variety of technology trends like millimeter wave transmission, edge compute, artificial intelligence, zero-touch management, distributed ledgers, and the like. IETF, IEEE, and ultimately things feeding into the 3GPP, which already started the advancement of 5G with the release 1718, and anticipated actually to culminate with the 6G, first 6G specification around the time frame of 2026, with a few releases up until 2030. So moving on next with this IMT, the ITUR. So as I just mentioned earlier, the ITUR already issued recommendation in February this year for IMT 2020. And essentially the terrestrial radio interface, non-surprisingly, was the 3GPP 5G submission, based on the 5G submission from 3GPP. So this is like a milestone, major milestone that's ticked, and it didn't take long for the ITU to already actually start working towards the IMT 2030. So there's already an activity ongoing into the ITU or under this so-called vision and future technology trends towards 2030 and beyond. And this has been attracting a lot of contributions with anticipated completion of this report in June 2022. So let's maybe take a little bit of a look on how this ITUR, what are the pillars of the ITUR IMT activity. So these turn around services, spectrum, and performance. So this is exactly what the ITU mission or charter is. Kind of laying out the vision, what services need to be supported, what kind of spectrum, either additional spectrum or existing spectrum need to be allocated to support the services vision. And then once the specification is done in the standard bodies, like the 3GPP, for example, right? So this is when the ITU will double check actually the performance of these specifications, if they meet or not the requirements that are laid out to support the services. And assuming that these specifications meet the requirements, then the ITU will issue official recommendation that, for example, a spec from 3GPP is, let's say, IMT 2030 rubber stamp. So here on the services side, there is an emerging consensus that we are moving towards extreme services with extreme requirements, spectrum as well, moving to extreme frequencies above the 100 gigahertz cap in IMT 2020. And then in terms of performance, obviously extreme requirements means extreme performance. So trying to achieve significant gains in every single dimension with that famous spider diagram. Now, what are the services? So the services underpinning 5G evolution to 6G. So these are like the multisensory extreme reality, smart industries, private, personal, and local networks, non-terrestrial services, satellite services, UAVs, massive IoT, future railways, advanced vehicular V2X services. So you might say, oh, well, we have seen all these already in 5G, which is true. But each of these actually categories of services has a rich roadmap on its own that require evolution of today's 5G specifications all along until 6G and even beyond. So these are with us to stay as we evolve 5G all the way up to 6G and beyond. So moving next from the services to the spectrum and performance capabilities. So this is mostly with focus on the radio interface side. So here we are seeing, so in green, we put in the current values of these capabilities as they are specified in the IMT 2020. And then we show that in blue, the direction of travel of these capabilities up until IMT 2030. So just to take a few examples here, if you take the spectrum, so we know this spectrum is limited in IMT 2020 with that cap of up to 100 gigahertz. So this is, and even though we have this cap today in IMT 2020, there are no systems that are achieving yet above 52.6 gigahertz and accredited by the ITUR as IMT 2020. Okay? So as a direction of travel from this cap of 100 gigahertz, it is envisioned or forecasted that we will see frequencies moving further up, breaking that cap of 100 gig, going all the way up to 300 gigahertz by the 2030. Of course, this will happen gradually and not overnight. We will change from 100 gig to 300 gigahertz. And obviously, as you move up in the frequencies, then we have opportunities to expand the bandwidth, maybe by a factor of 10, up to 10 gigahertz from today's up to 1 gig. And then this will translate into higher data rates, peak data rates, user data rates, both uplink and downlink. Also on the latency side, which is really critical, especially for autonomous vehicles, connected industries, and tactile use cases. So we anticipate latency to improve from today's IMT 2020 figures. Going to the below a millisecond or sub-millisecond in the new plane side, and then below a 5 millisecond in the control plane side. Reliability is anticipated to improve as well, connection density, energy efficiency, positioning accuracy, and the mobility as well. Now, so these are like the forecasted capabilities for the IMT 2030. So what kind of technology actually can help us meet these forecasted capabilities? So this is what actually this slide is about. Again, so it takes multiple technology components on the left-hand side in that purple background kind of boxes. And then it shows the state of this technology in today's IMT 2020 systems. And then it, in blue, it kind of lays out a roadmap on each of these technology, how we see the progress and the enhancements happening for each of these technology elements. So again, if we take that example of the moving towards higher frequencies, right? So today we go up to 52.6 gigahertz, even though, as I said before, IMT 2020 goes up to 100 gig in terms of frequency cap. So we already seen enhancements actually happening, but still under the cap of 100 gig. For example, in the 3GPP in the release 17 and 19, going to the 71 gigahertz frequencies, right? And another fora like in the ETSI MWT already exploring some of the frequencies above 100 gigahertz, mostly in the 140, 150 kind of gigahertz. So this trend is for enhancing the design of wireless systems above 100 gig, above 50 gig, let's say, and maybe up to 170 gig will continue up until 2023. Before actually we break that cap of 100 gig around the 2024 kind of time frame. And we'll see immediately as we break that cap, I think we'll see some new design that's required, some further leveraging of this artificial intelligence, especially for the spectrum management side, and then some form of joint sensing and communication, especially as we move up to these very high frequencies. Then the woods of communication and sensing start to blur, and we anticipate some form of convergence happening in there. And then further on, as we continue our journey to higher frequencies in the 2028, 2030, so we anticipate again another wave of new design for the spectrum up to the 300 gigahertz, further on with perhaps a full integration of that sensing and communication capabilities. So for the sake of time, I'm not going to go through every single component here, but I just wanted to illustrate the approach we followed in terms of road mapping these wireless technologies from 2020 to 2030 in a way to meet the capabilities that I outlined earlier. So to pick up maybe another example here, if we take massive MIMO today, so it's pretty much centralized architecture up maybe to 256 kind of antenna arrays dimensions, and it's between digital and analog beamforming. We are already seeing extended enhancements to the MIMO, to the beamforming for support of higher frequencies and multi-users. In the midterm, 2024, 2026. So this is when we envisioning larger antenna arrays, maybe with 512 kind of antenna elements, super directivity at higher frequencies, and distributed and coordinated multi-point schemes, making finally perhaps a commercial reality. And then as we contemplate the longer term evolution of massive MIMO. So this is where we have technology trends around holographic beamformings, 1024 kind of antenna arrays, meta surfaces and reconfigurable intelligent surfaces, and obviously the leveraging of AI to minimize the complexity and the cost of these ultramassive MIMO schemes. All right, so moving next, in the same way I did for the wireless technologies, obviously the 6G is not going to be only the radio interface. There are also network technologies that need to be considered as well. And pretty much the same approach we followed in road mapping the wireless technologies, we followed it here with the network technologies. So even though there is no reference like IMT 2020 for the network technologies, so we did our best here to illustrate, the consensual, let's say, or the consensus on these technologies as the state of art today, and how we see the future looking for these different network technology trends. So if we take, for example, edge computing as an example, again here, so today we have edge cloud solutions, and there's some ongoing specification that's happening in ETSI MEC and in the 3GPP as we contemplate actually the short term in terms of edge native compute. So it's really moving towards a full integration of edge with 5G, but also importantly moving more towards a distributed edge enhancements, right? And as we look at the midterm, so this is when topics around inter-edge interworking and federation are anticipated, but also move to support the edge or to expand the edge, if you like, to constrained devices, so mobile and power constrained devices. So we can envision let's say the smartphone or the car to be an edge host. So these will take some time until they become fully specified and realizable. And as we look actually at the long-term component of this technology trend of the network, so this is where we see a full leveraging of AI into the edge, for example, and then a full seamless integration across the different domains and different tiers of the edge. So the far edge, the edge, and then perhaps some upper tiers of the edge on the cloud as well. So this is again to give you some, as an example of network technology trends that's anticipated. If we take another one on the slicing side, so this is a key feature specified today in 5G that continues to be improved in 5G, 3GPP, especially with enhancements around in the short term around improving or improved control of these resources and inter-slice interworking. And as we look at the mid and long term, so this is where we need actually the slicing to be done on the fly in terms of creation and sensation, but also importantly, the scaling of the slices to happen in real time and on the fly. Right, so I'm going to stop here actually on the technology trends and conclude my talk. Really what I wanted to communicate as takeaway today is that yes, we are in quite early stages today in terms of rollout of 5G. And we still have a long way to go with the evolution of 5G, incremental evolution of 5G. Now, that said, it's time now actually to think of what's coming up next. And the emerging use cases for the evolution of 5G all the way up to 6G, as I outlined earlier, so they seem quite familiar. So these are not like completely new, none heard of kind of use cases. So these are use cases heard of in 5G, but they have not been actually fully supported, and they are rich in requirements and that will take us until 6G and even beyond 6G to get all these use cases supported. And these use cases, they are pushing for extreme requirements. So that will continue to push the evolution of wireless well beyond 5G and 6G. And looking out to the future on the promising technology trends, so it appears indeed that we will have inflection points that will may lead to a 6G by 2030 that's not backward compatible with the 5G and its incremental backward compatible evolution that's happening today in fora like in the 3GPP. So with this, I conclude my talk and just acknowledge some of the projects and importantly 5G clarity into feeding into this road mapping activity that I just presented to you today. All right, so that's it really from me.
Thank you very much, Alan, for your great information, your great presentation, a pile of information on trends, technology trends, and forums and regulations and everything toward 6G, very well categorized. We can have, please post any questions to Alan to the chat box, and we can use the discussion and a Q&A session for any question on your presentation. Thank you very much.
Thank you.